The year 1938. Berlin. The Reich Air Ministry. A group of high-ranking officials stared at the blueprints lying before them on the table, their faces turning pale with horror. What they saw contradicted all the laws of aviation engineering and common sense. Before them lay the design of an aircraft whose crew cabin was not located in the center of the fuselage, like all normal machines, but was shifted to the starboard side. The engine, however, was on the left, creating an absolutely asymmetrical construction. One of the officials clutched his head and shouted that this thing would never be able to lift off the ground, that it would immediately roll over and kill the pilot. Others nodded, fully agreeing with their colleague. But the author of the project, 40-year-old aircraft designer Richard Vogt, stood before them with a stone face and unwavering confidence in his eyes. This man had gone through the trenches of the First World War, had flown fragile airplanes over battlefields, and was not so easily broken by the words of officials. Vogt was known in aviation circles as a stubborn innovator, a man who never followed beaten paths and always sought revolutionary solutions where others saw only traditional approaches. The story of this incredible aircraft began several months earlier when the Reich Air Ministry announced a competition to create a new single-engine reconnaissance aircraft. The requirements were clear and stringent. The machine had to carry a crew of 3, possess excellent visibility for observing enemy territory, and at the same time remain fast and maneuverable. The ministry particularly stressed that the aircraft must be precisely single-engine in order to simplify production and reduce fuel consumption. Leading German aircraft manufacturing companies Arado, Focke-Wulf, and several others were invited to participate in the competition. The Blohm und Voss company, where Vogt worked, was not even called because it specialized in seaplanes and flying boats, not land-based reconnaissance aircraft. But Richard Vogt was not one to sit quietly on the sidelines when an opportunity arose to create something truly revolutionary. Vogt had long pondered the fundamental problems of aircraft design. All aircraft of that time were built according to the same symmetrical pattern: engine in the front center, cabin behind it, wings in the middle, tail in the back. This scheme seemed logical and natural, but Vogt saw many flaws in it. First, the pilot observers sat behind a powerful engine that blocked their view forward and upward. Second, the rotating propeller created powerful air currents that battered the rudders and destabilized the flight. Third, and most interestingly, the torque from the engine constantly pulled the aircraft to the side, forcing the pilot to continuously correct the course. It turned out that symmetrical aircraft actually flew asymmetrically, and pilots had to fight the machine instead of having it obediently follow their commands. Vogt wondered, what if we create an aircraft that will be asymmetrical in design, but symmetrical in flight characteristics? What if we specially displace parts of the aircraft so as to compensate for all those imbalances and inconveniences that conventional designs fight against? The owner of the Blohm und Voss company, Walter Blohm, turned out to be one of the few people who did not consider Vogt's idea madness. Blohm was a forward-thinking entrepreneur and believed that the future of aviation after the war would belong to civilian transportation, and military orders were just a temporary source of income. He dreamed that his company's seaplanes would one day replace ferries and passenger ships, transporting people between continents and countries across oceans. Therefore, Blohm always encouraged innovations and non-standard solutions that could make his aircraft stand out among competitors. When Vogt came to him with the blueprints for the asymmetrical reconnaissance aircraft, Blohm saw in this not only military potential, but also an opportunity to make the company famous throughout the world. He gave the green light for development, even though the Air Ministry had not even invited them to participate in the competition. Vogt and his team of engineers set to work with incredible enthusiasm. The designer decided to place the BMW 132 engine on the left side in a separate fuselage that extended to the tail assembly. On the right side, there was a fully glazed plexiglass gondola housing a crew of 3, a pilot in front, an observer in the center, and a gunner with a machine gun in the rear. This gondola was attached to the wing and provided a completely fantastic view in all directions. The crew members could see the ground beneath them, the sky above their heads, the space to the sides, and even behind without any obstacles. No other single-engine aircraft could boast such visibility. The wing connected both parts of the structure and was specially calculated so that the distribution of lift compensated for the asymmetrical weight distribution. Vogt conducted the most complex mathematical calculations, proving that the aircraft would be stable in flight. The first prototype was ready by the end of 1938. When the mechanics rolled the machine out onto the airfield, everyone present froze. The aircraft looked as if it had been assembled from parts of two different machines. The test pilot who was to take this structure into the air walked around the aircraft for a long time, shaking his head and muttering something under his breath. He did not believe that this thing could fly normally. The ground crew was also nervous. Many placed bets that the aircraft would either not lift off the ground or would immediately roll onto its side after takeoff. Vogt stood aside, clenching his fists, but outwardly maintaining composure. He knew that if the first flight failed, his career would be ruined, and the idea of asymmetrical aircraft would be buried forever. The engine roared, the propeller spun, and the aircraft began its run down the runway. The speed grew, the structure shook and rumbled, but held straight. Then the nose lifted and the machine broke away from the ground. For a few seconds, all observers held their breath, expecting a disaster, but the aircraft continued to gain altitude smoothly and confidently, as if mocking all the skeptics. The pilot made a circle over the airfield, performed several maneuvers, and landed safely. Climbing out of the cabin, he was pale and agitated, but his first words were that this machine flies better than many conventional aircraft. There were no roll problems. The control was sharp and predictable, and the view from the glass gondola truly surpassed everything he had seen before. The news of the successful tests quickly spread through aviation circles. One of those who became interested in the unusual machine was Colonel General of the Luftwaffe, Ernst Udet, a legendary ace pilot of the First World War and one of the closest associates of Hermann Göring. Udet was not just an official. He was a real pilot who understood aviation and valued bold technical solutions. When he was shown the test results of the BV-141, as the new aircraft was named, Udet demanded a personal demonstration. Vogt gladly agreed. Udet arrived at the airfield, inspected the aircraft, asked many technical questions, and even went aboard himself as an observer. After the flight, the general was delighted. He declared that this aircraft met practically all the ministry's requirements and even surpassed them in some parameters. Udet promised Vogt his support and began promoting the project in the highest echelons of power. However, not everyone shared Udet's enthusiasm. Hermann Göring, Supreme Commander of the Luftwaffe and one of the most influential people in the Third Reich, treated the asymmetrical aircraft with deep skepticism. Göring was a conservative in matters of aviation technology and preferred proven traditional designs over experimental novelties. When he was reported about the BV-141, he called the project a circus trick and expressed doubt that such a machine would ever be adopted into service. Göring openly supported Vogt's competitors, especially the Focke-Wulf Company, which presented its reconnaissance aircraft, the FW-189, nicknamed Uhu, which meant Eagle Owl, to the competition. This aircraft had a classic twin-boom scheme with two engines and a fully glazed central gondola. Formally, the FW-189 violated the ministry's requirement for a single-engine design, but Göring turned a blind eye to this, considering a twin-engine aircraft more reliable and safer. The Arado Company did not sit idly by either. They developed their version of a reconnaissance aircraft under the designation AR-198, which the Air Ministry initially planned to adopt into service without any competition. Officials had practically promised Arado the contract, but when the prototype was finally built and tested, it turned out that the machine was frankly a failure. The aircraft showed poor flight characteristics, was unstable in the air, and did not meet the declared requirements. After several test flights, the AR-198 project was definitively canceled, and all the hopes of the officials shifted to Focke-Wulf. This gave a chance to Vogt and his creation, but only if they could prove the superiority of the asymmetrical design over the traditional twin-engine Eagle Owl. On April 4, 1940, official comparative trials of the BV-141 and FW-189 took place. The Air Ministry Commission arrived at the proving ground to see the capabilities of both machines with their own eyes. The tests included checking speed, maneuverability, stability, cabin visibility, and the ability to conduct reconnaissance from various altitudes. Both aircraft showed good results, but the BV-141 had several important advantages. Its single-engine design made the machine simpler to maintain and cheaper to produce. The view from the fully glazed gondola turned out to be even better than that of the FW-189, thanks to a larger glazing area and the absence of obstructing structural elements. In addition, Vogt's asymmetrical aircraft demonstrated excellent handling and stability, completely refuting the fears of the skeptics. In its conclusion, the Commission wrote that the BV-141 met almost all the mission requirements and showed great potential as a reconnaissance machine. Udet took advantage of these results and began actively lobbying for the project in the ministry. He convinced the officials that the asymmetrical aircraft was exactly what the Luftwaffe needed for effective reconnaissance on all fronts. Despite the resistance of Göring, who continued to insist on the FW-189, the Air Ministry in 1939 made a decision that shocked the entire aviation industry. An order was placed for 500 BV-141 aircraft. This was a triumph for Vogt, for Blum, and for the entire development team. Their creation, which until recently had been called madness, was now to become a mass-produced reconnaissance aircraft for the Luftwaffe. In the plans of the military command, the BV-141 was to be used in all theaters of military operations, but special hopes were placed on the Eastern Front, where a large-scale invasion of the Soviet Union was being prepared. Vogt's team rejoiced. Engineers embraced, mechanics opened bottles of champagne, and the designer himself finally allowed himself to smile. Years of hard work, fighting against bureaucracy and skepticism, had paid off in full. The Blohm und Voss company received a huge contract that was to keep it busy with work for years to come. Preparation for mass production began. New workshops were built, equipment was purchased, and additional workers were hired. Designers were already working on an improved version of the aircraft with more powerful engines and enhanced armament. It seemed that a brilliant future awaited the asymmetrical reconnaissance aircraft, and it would become one of the symbols of German aviation. Military planners were already developing tactics for using the new machines, training pilots and observers, and making plans for reconnaissance operations deep within enemy territory. The use of the BV-141 for scouting Soviet fortifications, airfields, and troop concentrations before the start of Operation Barbarossa was discussed particularly actively. But the euphoria did not last long. As the engineers delved into the preparation for series production and built new prototypes, serious problems began to surface, which had previously either gone unnoticed or been considered insignificant. The first and most dangerous problem concerned the crew. That very same fully glazed gondola, which provided excellent visibility and was considered the main advantage of the BV-141, turned out to be a deadly trap in combat conditions. Glass, even armored glass, could not protect the pilot, observer, and gunner from bullets and shrapnel. Any enemy fighter or anti-aircraft installation could turn the transparent cabin into a sieve in a matter of seconds. The crew members were essentially sitting in an aquarium, completely exposed to enemy fire. Military pilots who were supposed to fly these machines began to express serious concerns about their safety. Several pilots directly stated that they did not want to go up into the air in an aircraft where they would be visible to the enemy as if in the palm of a hand, and at the same time practically defenseless. The second problem was purely technical. The rudder, located on the tail assembly, constantly experienced excessive aerodynamic drag. Air currents from the propeller and from the asymmetrical fuselage created turbulence that battered the rudder and made control difficult. Pilots had to exert additional effort to maintain course, especially at high speeds. This was not critical for short test flights, but in long reconnaissance missions that could last for several hours, the constant struggle with the rudders exhausted the pilot and reduced the crew's effectiveness. Engineers tried to solve the problem by changing the shape and area of the rudders, but each change caused new difficulties with balancing. The third problem arose when machine guns and additional equipment began to be installed on the aircraft. The weight of the machine increased, and it turned out that the wing was not long enough to maintain the correct balance. The right side with the heavy gondola and armament began to outweigh the left side with the engine. The wing had to be lengthened, which in turn increased the overall weight of the structure and reduced speed. Every fix of one problem generated two new ones, and engineers got bogged down in an endless cycle of refinements and modifications. Vogt was in despair. He understood that his creation, which had shown itself so brilliantly in the first tests, was turning into a capricious and problematic machine that required constant compromises. Nevertheless, work continued. By 1941, 3 fully fledged prototypes had been manufactured for advanced testing, as well as a batch of 5 version A machines for evaluation trials in the troops. These aircraft were equipped with BMW 132 engines with a capacity of 1,560 horsepower, which provided a maximum speed of about 438 kilometers per hour. The flight range was approximately 1,900 kilometers, and the ceiling reached 9,700 meters. The characteristics were quite decent for a reconnaissance aircraft, but the military wanted more. They demanded a more powerful engine, greater speed, and better crew protection. In response to these demands, the designers developed an improved version B, which was to become the actual production variant of the aircraft. The BV-141 version B received significant changes. The most important was the installation of a new BMW 801 engine, which put out an impressive 1,560 horsepower and allowed for much greater speed. The tail assembly was redesigned, making it asymmetrical. The right part of the horizontal stabilizer was removed completely to improve the view and the field of fire for the rear gunner. This was a bold solution that further enhanced the unusual appearance of the machine. Now the aircraft looked absolutely fantastic. Engine on the left, cabin on the right, and even the tail was crooked. They strengthened the armor of critical components, although they still failed to fully protect the glass gondola. More powerful armament was installed, including additional machine guns for defense against fighters. By the end of 1941, 12 production version B machines had been manufactured, and they were undergoing intensive testing. The results were contradictory. On the one hand, the new engine did indeed improve characteristics, and the aircraft became faster and more maneuverable. On the other hand, the problems with crew vulnerability had not gone anywhere, and the complexity of the design made production slow and expensive. Each BV-141 required significantly more man-hours to assemble than a conventional symmetrical aircraft. The asymmetrical design meant that practically every part was unique. It could not be interchanged between the left and right sides as in normal machines. This complicated logistics, increased the number of necessary spare parts, and slowed down production rates. It was at this moment that the Air Ministry made a fatal decision. Officials analyzed the situation and concluded that the BV-141 was too complex and expensive for mass production. In wartime conditions, when thousands of aircraft were required in the shortest possible time, an unusual asymmetrical design was a luxury that Germany could not afford. In addition, it turned out that the powerful BMW 801 engines were acutely needed for the latest Focke-Wulf 190 fighters, which were supposed to defend the skies of the Reich from Allied air raids. Each engine installed on a BV-141 reconnaissance aircraft meant one less fighter at the front, and fighters were far more important for the survival of the country than experimental reconnaissance aircraft, no matter how good they were. The ministry decided that the existing fleet of Focke-Wulf 189 aircraft was quite sufficient for reconnaissance tasks. These twin-engine Eagle Owls had proven themselves to be reliable and efficient machines. Their production was well established, and there was no point in switching to a new, complex design. The order for 500 machines was cancelled. Production was stopped at 12 finished copies of version B. Although, according to German archival documents discovered later, about 20 aircraft were actually manufactured in various versions, if one counts all prototypes and experimental models. For Vogt's team, this was a crushing blow. Years of work, all those sleepless nights over blueprints, all the arguments with officials, all the tests and refinements turned out to be in vain. The aircraft that was supposed to revolutionize reconnaissance aviation remained merely an interesting experiment. Richard Vogt was crushed, but he was too stubborn to give up completely. He continued to work on improving the design, hoping that the ministry would change its mind. Plans were developed for 38 different modifications of the BV-141, including variants with different engines, armament, and equipment. But all these plans remained on paper, and then an event happened that finally buried the project. In 1942, Allied aviation conducted a massive raid on German industrial facilities. One of the targets was the Focke-Wulf Company plant in the city of Bremen, where 4-engine FW-200 Condor aircraft were produced. These machines were used as long-range reconnaissance aircraft and bombers, patrolling the Atlantic and hunting for Allied convoys. But most importantly, one of the Condors was the personal transport aircraft of Adolf Hitler, who used it for flights between headquarters and fronts. The Allied bombing practically destroyed the plant in Bremen. The workshops burned, the equipment was ruined, and Condor production stopped completely. This was a catastrophe for the German aviation industry. The High Command urgently sought a solution to the problem. Condors were needed immediately, especially to support operations against the Soviet Union, where they were to be used as heavy bombers. The gaze of military officials fell upon the plants of the Blohm und Voss Company. They had suitable production capacities, qualified workers, and experience in building large aircraft, albeit seaplanes. The Air Ministry ordered Blohm und Voss to immediately cease all its own projects and switch to the production of FW-200 Condor aircraft under license. This was an order that could not be discussed. Walter Blohm was furious but could do nothing. All his company's resources, all the workshops, all working hands were reassigned to assembling someone else's aircraft. The BV-141 was no longer needed by anyone. Several finished machines simply stood on the airfield, slowly deteriorating under the rain and snow. Not a single BV-141 ever saw real combat. Not one of these machines flew on reconnaissance over the Soviet Union, as had been originally planned. Several aircraft were used for training flights and testing new equipment, but there were no combat sorties. The plan to send asymmetrical reconnaissance aircraft to the Eastern Front remained unfulfilled. By the end of the war, most BV-141 aircraft had been either dismantled for parts or destroyed during the retreat so that they would not fall to the enemy. When the Allies entered the territory of Germany in 1945, their soldiers discovered the wreckage of several strange aircraft with an asymmetrical design. Military specialists were intrigued. What kind of machines were these? For what purpose did the Germans build aircraft with a cabin shifted to the side? British troops captured at least one more or less intact copy of the BV-141 and sent it to England for detailed study. Engineers of the Royal Air Force dismantled the aircraft to the last bolt, studied every element of the design, and analyzed the aerodynamic solutions. Their conclusions were contradictory. On the one hand, they recognized the boldness and originality of the concept, as well as the quality of the engineering work. On the other hand, they agreed with the German military that such a machine was too complex for mass production and too vulnerable in battle. Entries in the bibliography of scientific and industrial reports of the Allies indicate that the United States Army Air Force's Materiel Command also gained access to at least one BV-141 for testing and study. The Americans were also struck by the unusual nature of the design, but came to the same conclusions. An interesting experiment, but an impractical combat aircraft. In total, according to German archives, 20 BV-141 machines were built in various modifications, including prototypes, evaluation version A models, and production version B machines. Most of them never took to the sky more than a few times. Some were used exclusively for ground testing of systems and equipment between 1939 and 1940. Not a single one of these aircraft has survived to our day. All of them were either destroyed during the war or dismantled by the Allies after study. Not a single museum exhibit, not a single restored machine remains. The asymmetrical reconnaissance aircraft exists only in photographs, blueprints, and in the memories of those few people who saw it with their own eyes. As for the creator of the BV-141, the fate of Richard Vogt turned out unexpectedly. After the capitulation of Germany, American intelligence agencies launched an operation under the code name Paperclip. The goal of the operation was to export German scientists, engineers, and designers to the United States so that they would work for American science and industry. Vogt was included in the list of valuable specialists, thanks to his experience in creating non-standard aircraft designs. He was transferred to America, where he continued to work on experimental projects. His interest in unusual aircraft had not gone anywhere. In the United States, Vogt participated in developing the concept of bombers with nuclear propulsion systems. Fantastic machines that were supposed to fly for weeks without refueling. Later, he got a job at the Boeing Corporation, already as a civilian specialist, and worked there on various projects until his very retirement. The man who created the strangest aircraft of the Second World War finished his career in the peaceful post-war aviation industry. The BV-141 remained in history as one of the most unusual and bold experiments in aircraft manufacturing.